Hello there everyone, it is KP the MFG once again. We have been approximating area under a curve. This curve is f at x equals 16 minus x squared. It is not drawn to scale. 16 is either way up high or 4 is much further in, but because we need to see the whole picture, I need to get this on out there a little bit, okay? And so that's why it looks like it's the same distance almost either way, but we're going to say it's not drawn to scale, which it is not. Okay. N is 4, which means in this case we're doing the trapezoidal rule, so we need 4 trapezoids. We want 4 trapezoids. Delta x, we looked at this before, but I want to show you again. Delta x is b minus a over n. Well, what does that mean? Well, b, let me write this down. Here is a, here is b, and n is already here, okay? So 4 minus 0 divided by 4, 4 over 4 is 1. That's how wide this is. So in this case, this is delta x, which is 1 down here. We know that's 1 unit here, 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 and here. Okay, so we're going to be evaluating the areas of that we're going to sum up the areas of 4 trapezoids. Okay. This is generally what a trapezoid looks like. They can be drawn in so many ways. I could have this taller than this, or I could have 2 ends that are like this so far. But anyway, this is the look I want to have because this is slanting this way. I want this to slant down this way as well. It is, usually we say base 1 times base 2 times the height, but since these are heights, we're going to call this h1 times h plus h2 times b. So here's what we have here. Yeah, the area, and by the way, is h1 plus h2 divided by 2 times b, which in this case is delta x. Okay, that is the area of the trapezoid. Okay, and so we're going to have several of these. I'm going to need a little room to write. I'm going to erase all this in just a little bit, but this is the idea behind it. Alright. Sometimes we need to be reminded what the area of anything is. Sometimes I need to be reminded what the area of a trapezoid is. Alright. And I'm going to erase this because we're going to need the room. I might leave this up here for the time being. What I want to do is draw 4 trapezoids here. Okay. We're going to start at 1 right here. Go straight up. And we're going to make a trapezoid out of this. Okay. It's supposed to go straight to the line here. Okay. Point here. Okay, like that. Alright. There's that. Alright. And straight up till we get to the line here. And we're going to make a trapezoid here from here to here. Alright, and then we're going to do it again, straight up till we stop. And we're going to make a trapezoid here like this. Wow, it's clinging pretty close to the curve, isn't it? That's pretty cool. And then of course this one here, which we really don't have. Okay, so 1, 2, 3. Well, we want to make a trapezoid here, but this is 0 here. It comes all the way down. It's not much of a trapezoid at all, even if we were to come up at all. I don't even know. We'd have to create a trapezoid here, you know, somehow or another. But anyway, this is that 0 here, so it's kind of difficult to make a full trapezoid. Even if we were to come up at all, we'd have to come way down like this. And so which really we would not be able to do very much here. But anyway, that's the idea. This is going to be, we're going to try to make it clean a little closer. Okay. I don't know. Well, anyway, 4 trapezoids is what we have. Of the same width, delta x is equal to 1. Alright, so let's see what we can do with this. Okay. Okay, so incidentally, when we start to look at these trapezoids, and we know it is from 0 to 4, I think we already have all this. We're going to need all the little area we can get right here. Okay, right here. This would be good. We might could work in this area here. Okay. Alright, so right here, this is, we might call this H1. We know this is 1 unit, and so is this one, and so is this one, and so is this one. Each one of these delta x's is equal to 1. Okay. Now this is height 1, height 2, height 3, and height 4. The 4th height right there. Okay. Now, let's take a look at this. A height, by the way, we talked about it in our last, this is actually equal to the height. Alright, that's actually how high it is, y. Alright, y, h1, whatever you want to call that, h sub I, whatever it is. Okay, this y is the height. It is this right here. Alright, so really in the first one, where 0 is, this is L fat 0. Okay, this is L fat 1. Okay, L fat 2. L fat 3. Okay, and not sure if we need an L fat 4, but if we do, it'll be down here. L fat 4. Okay. Alright, so here's what we're going to do. We're going to have 4 trapezoids. We want to look at these areas. This is area 1 plus area 2 plus area 3 plus area 4. We're going to sum them up from I equals 1 to 4. Okay, and we're going to come up with f at xi delta x, like this. We're going to sum up all these f's here, alright, and also the delta x we already know to be 1. Okay, that's the summation symbol there. Alright, so this is what we're doing. Alright, so the area of a trapezoid. Let me turn my phone off. It gives me notifications when I don't even want to be notified, but it's okay. So let me turn this off. Sorry about that, everyone. Okay. I should have turned this off from the start. Okay. Now let's go ahead and take a look here. Remember we said this was height 1. Each one is, okay, so this should be maybe h of 0. This should be h of 1, h of 2, h of 3, like that. And then if there is a height here, that would be h of 4, but anyway, like that. So it'd be h of 0. Here's what we do. We got, it is going to be equal to, alright, the area is equal to Alright, so it's going to be 1/2. I'm always multiply by 1/2. Alright. Base height 1, height 2. So it would be h0 plus h1, and that's already times, well, it's already times that. Okay. Let's put it where we can read it a little better than that. I'm so sorry today. I don't know. I just gotta get it together today. Alright, h0 plus h1. Okay, and then another 1/2, the second one, alright, that's this one here, h0, h1. Okay, now we want to do h1 plus h2. Okay, h1 plus h2. Okay, here we go again, h2, h3, that's 1/2, h2 plus h3. Alright, let's see, well, and also delta x is 1, so I guess we could have said a times 1 each time, times 1 times 1, okay, which is that anyway. Alright, and then plus 1/2 h3 plus h4. Okay, now we can factor out the 1/2, can't we? I'm sorry, I'm dropping everything. Alright, so I'm going to take out the 1/2 delta x. Alright, so if I do that, it's going to be 1/2 and then times 1, really. Delta x is 1. Alright, so that's going to be HO plus H1 plus, alright, already taken out a 1/2, so that's going to be H1 plus H2 plus, taking out a 1/2 here. Alright, so that would be H2 plus H3 plus H3 plus H4. Alright, you see where I got all this from. H0 plus H1 right here. Alright, taking out the 1/2. Alright, that just leaves me with this right here. If I take out the 1/2 here, it leaves me with H1 plus H2. Remember, we're summing all this up. Alright, there's this one, and then this one, and then H2 plus H3, we took out this one, and then H3 plus H4 is this one. Now, let me, we're down to here now, so let me go ahead and I'm going to erase. I don't want to flip this over just yet, so I'm going to go ahead and just erase this, so bear with me while we erase this. I need the room on this side. I want you to see it all from this side. Alright, maybe I'll use a different color also. Alright, so that's your trapezoid right there. But we can combine some terms. Look at this right here. I'm going to get a different color. Bear with me, guys and girls. Do we see that we have H1 plus H1? We have two of them, don't we? We have two H2s. We have two H3s. But we only have one H sub 0 and one H of 4. Now remember, we said H of 0 is really alpha at 0. That's the same thing as the height. Alright, so what we need to do is substitute F at 0, F at 1, F at 2, and so on. Alright, so 1/2 times 1 is 1/2. So the area is equal to 1/2. Alright. HO, that's F at 0. Alright. Now, H1 plus H1 is 2 H1s, but that's 2 alpha 1s. Okay. And then, well, let's put it down here, plus, okay, H2s, we got two of them, all right, so H2s, so 2, F at 2s, okay, and then we got 2 F at 3s, and then plus F at 4. Okay, like that. Okay. Alright. Now, let's see what each one of these are. From previous lessons, but if you haven't been here, if you haven't tuned in on this and you just want to see the trapezoidal rule, this is F is 0. Now, F is 0 right here. This is the height. Alright, the first height. I'm just going to plug 0 in right here. Everything is plugged in to this X right here. Okay? So F at 0 is 16 minus 0 squared, which is just 16, isn't it? So F at 0 is 16. I got to erase as we go. Okay, F at 0, so 1/2. Alright, it's 1/2. Alright, F at 0 is 16. Alright, plus 2 times F at 1. Alright, so F at 1 is equal to 16 minus 1 squared, which is 16 minus 1, which is 15. Alright, so 2 times 15. Alright, 2 times 15. I already know these by heart. The next one is going to be 7. Okay, this here. Alright, 2 times. Alright. Alright, I already checked off F0, F1, F2. F2 is going to be 12. That's right. So 16 minus 2 squared is 16 minus 4, which is 12. Okay, so 12 here. Okay, then the next is 7. Alright, plus 2 times. Okay, so let's see. So that's going to be, so it's getting crowded here, isn't it? Let's put it up here. F at 3 is 16 minus 3 squared, which is 16 minus 9, which is 7. Okay, and we really, on the last one, do not have a bona fide trapezoid, but we're going to treat it as if it is one, because watch here. F at 4 is 16 minus 4 squared, and you can see what that is, right? So 16 minus 16 is 0 here. So in this case here, plus 0. Alright, so remember the first and the last terms, you'll start with F at 0 and F at whatever n is. So F at 0, and it could be that the first one's a 1 or 2 or whatever. Wherever it starts at, usually it's F at 0, and then it ends somewhere. So we had F at 0, F at 4, but 2 times F1, 2 times F2, 2 times F3. In between, it's 2 times. Okay, because you simply got 2 of each one of these. We looked at that earlier. Just like this, right here. Right here. 2 of these, 2 of these, 2 of these. There's 2 of these, 2 of these, 2 of these, 1 of these, 1 of these. Okay, make sense? Okay. So that's really, if you can kind of get that formula set straight in your mind about a trapezoidal rule, you got this. Now let's do a little figure. Now remember, in the end we're going to multiply by 1/2. Alright, so 16, 2 times 15 is 30, 2 times 12 is 24, 2 times 7 is 14, and then plus 0. Alright, there it is. And let's see, we'll just do a little arithmetic here. That's equal to 1/2. Okay, let's see. 16 plus 24 is 40. Alright. So 40 plus 30 plus 14 is 44. Okay. And now this is 1/2 times 88. 84 rather. You know, I can't count. I am KP the Math G. Has nothing to do with being KP the Math G. You just got to be able to add it up right here. Alright, here we go. Half of 8 is 2. Half of 8 is 4. Gracious! Half of 8 is 4. Half of 4 is 2. Alright, there we go. That was 42. Now, I want you to, that's 42 units. Okay, whether that's in feet, whether that's in amount of water, okay, maybe gallons of water, maybe pints of oil, okay, quarts of asparagus, I don't know. Okay, I don't know, I'm just talking. Alright, anyway, 42. A little observation here, okay. When we did the left approximation, we're just going to just say left, we got an answer of 50. When we did the right approximation, we got an answer of 34. When we averaged these two, we got exactly what the trapezoidal got us, and this is 84 over 2, which is 42. If you do the left-hand rule and the right-hand rule and take an average, you've just done the trapezoidal. Okay? Every single time. Remember, we just got on a trapezoidal. A trapezoidal rule, we got 42. The midpoint, on the midpoint rule, we got 43. Okay? The actual answer to this is, and we're summing up, and we haven't done this before, not on a video. You may have done this before, but from 0 to 4, summing up from 0 to 4, 16 minus x squared, that's your heights, delta x dx. Okay, if you know how to do this, you can find this answer. Okay, you know how to integrate, but do you know how? This is called a definite integral because it's from some number to some number. Okay. Now, if I were to integrate, I'm going to tell you the answer right now is 42.66666, which is 42 2/3. That's the answer. Alright. Alright, so notice that these approximations are fairly close, though not the exact one. It's not going to ever be exact, because you're going to have gaps in there, like we've shown before. This is actually equal to, if we take the antiderivative of 16, just add an x to the end, so 16x. Alright, minus, remember, add 1 to the exponent, so x3 over 3. And if you plug in both 4 and 0, it is actually F at A minus, or whatever, F at, well, B minus, if we call this B and we call this A, minus F at A. Alright, so what we got here is 16 times 4 minus 4 cubed over 3 minus 16 times 0, 0 cubed over 3. Well, we know what this is, right? This is all 0 here. Alright, so 16 times 4 is 64, and 4 cubed is 64 over 3. if I get a common denominator and I add those two together, I will get, well, I was trying to see what I would get. Okay, so I'm going to multiply 64 times 3. Alright, so let's see up here. Okay, 64 times 3. Get me a common denominator 3. Alright, 3 4s are 12, 3 6 are 18, 192. So 192 over 3. That's the same as 64. Okay. Alright, plus 64 over 3. Okay, and that, I'm going to get 42. No, I'm sorry. Let's see. 2 and 4 is 6. 6 and 9 is 15. Okay, and 256 over 3. So 256 divided by 3, 3/8. What's going on here? It should be minus here. Okay, that would make a whole lot of difference there. Whew, okay, now 12 minus 4 is 8. Now that makes a difference. 8 minus 6 is 2. 128. Now 128. That makes a world of difference. 4 times 3 is 12. So we know it's 40 something. We'll bring the 8 down, and 3 times 2 is 6. So 0.2, well, point and 2/3, 42, and 2 leftover thirds. And that's what I said we would get. That's the exact, that is the exact number here. So these, as we said, are one common word. Approx. They are all approximations. But when we take the definite integral, we will find the exact value. Okay, that's kind of what we're trying to do. That's what we're leaning into. We do all of this to finally get into this, which is a lesson in the near future for us. Okay, and what I want to do is I want to still do approximations on the next lesson. I want to do tables. I want to do approximations using tables. Maybe we might do a couple tables in one lesson, or just one table, and do all of these here with just one table. I don't know how long that's going to take me. I'm going to have to figure that out and see how long this is going to take. My video camera won't allow me more than 30 minutes and I want to say 20 seconds. So like I say, I need more memory in my camera, but that's neither here nor there. Okay, so anyway, this is the idea. We just did all of these. We just did the trapezoidal a while ago and got 42. If you want to look at all of these, you can. They're all on there in the last 4 videos, actually last 3. We did left and right first. We did midpoint second. This would be the 3rd one that we did, part 3 of approximations. And then part 4 we'll have to do with the tables. And we'll see if we can do all 4 of these at the same time. I don't know. We probably won't, but we may have to make a part 4 and a part 5. Okay? So anyway, I just wanted to get that across. And then we're going to, of course, get into the definite integral after that. So a whole lot left to do in the next following weeks. And I love to do this. I love to do this. I love to help you out. And again, please make sure that you hit the subscribe button. And also, if you want to make a comment, hey, well done, KP the Math G, or KP the Math G, I've got a better idea, but show me. And if you show me, you better be right, okay? That's all I'm saying. So I'm just saying, I want, I'm up for suggestions. I'm up for a better way, because I want to give you my best at all times. So once again, I do a clap signature ending. That's the way I always end it. I got to have my hands free to do that. So this is KP the Math G, beginning the new year. Matter of fact, January the 5th. So anyway, KP the Math G signing off. You guys and girls and whoever else is listening, have a great, great day.